First time in 27 years, a World Series game will be played in Candlestick Park, the Battle of the Bay.
It's 1989 in San Francisco, and just before Game 3 of the World Series, this happens. That earthquake took the lives of 63 people, injured thousands more, and caused about $6 billion in damages, which demonstrates just how impactful earthquakes can be.
Earthquakes are one of the most important natural disasters, and they can have detrimental and destructive effects on society. And so earthquakes need to be studied and they need to be researched so that we can understand how we can mitigate them, how we can prepare for them, and how we can even forecast them.
And that's just what USU researchers are trying to do, figure out if there's some reliable indicators to accurately anticipate earthquakes.
There are possibly 30, 40, 50 different controls that could be causing this. And so the question is, which of these is the primary control and how applicable is it globally in other places or even in the same location for the next earthquake?
So here in the lab, they use these bench models to try to apply the same principles that cause earthquakes, force and friction, and see what happens.
Faults in the nature are so large and it's so hard to study there. But in lab, we have like a 1 meter fault or a smaller 1 inch fault.
So essentially, here's what's happening. They pack a small amount of powdered rock between two plates and apply a vertical and a horizontal pressure. That builds up friction exactly like earthquakes do. And once it's built up enough, that happens. A series of tiny, tiny earthquakes.
Even though they're small magnitude earthquakes, like very small, like -2, we can still see that computer. And we're trying to mimic what we see here into a larger scale.
And what we do is we measure the strain accumulated over time and see if we can find any pattern that kind of gives us a hint or an idea if a rupture is about to happen or not.
And so this data they're collecting will help to improve on the current science around earthquake modeling.
We're working to fill those data gaps so that we can put them into models and simulations that will help inform people living in these areas about the hazards that earthquakes can cause.